Okay, so we know that the characteristic of position central of tendency, you took them. We talked about the mode, mean, and median. These are called the characteristic of position central of tendency. Uh, Locate the series around a central value, but sometimes these characteristics do not indicate uh, the variability around this value. Let's take an example. So here we have a family, two families of 5 children where their ages are the following. So this is the first family here, and this is the second family down. Okay, so these are their ages. If you find the mean of each family, if I find the mean here, x bar, you know how to find the mean. You add them up and you divide by their number. So here you do 13, 11 plus 13 plus 14 plus 15 plus 16 divided by the number of the children, which is 5. So over 5 you'll get 13.8. Same thing here, if you find the mean you'll get also 13.8. So we have the same mean. Also, if you find the median, so the central tendency around the median, you will find the median equal to 14. So we know that the median is the middle value. Okay, and also here the median, as you can see, it is 14. Okay, and don't forget, for the median you have to arrange them from least to greatest. Here they are already arranged. So we have the same mean and the same median. So um, we this example proves the necessity of calculating new characteristics for finding the variability around the value, and these new characteristics are called the characteristic of dispersion. So we'll talk first of all about the range. What do you mean by range? The range is the difference between the largest value and the smallest value of the variable. So let's take this example. Let's say you have this series of numbers 2, 3, 3, 5, 5, 8, 10, and 12. So what is the range here? We said it's the difference between the largest value and the smallest value. So what you have to do is to subtract the highest value minus the smallest value. You will get 10. So the range here is 10. So this is the first characteristic of dispersion. If they are grouped in a table, in the case where the statistical series is grouped in a table, how can we find the range? So let's take an example here. Okay, you look at your variable. My variable here are the grades xi. Okay, so here the highest value is 18 and the lowest value is 6. So the range is equal to 18 minus 6, which is 12. Okay, you don't look at the frequency, just look at the variable. My variable here are the grades, the highest value minus the lowest value. Okay, the second characteristic of dispersion is called absolute mean deviation. What do you mean by absolute mean deviation? You have already watched the video about the meaning of absolute mean deviation, but briefly, the mean deviation will be denoted by small e. So this small e means absolute mean deviation. It is the mean of the absolute value. So when I say the mean here, I mean the average of the absolute values of the deviation from the mean. So this deviation gives you a good idea about the variability of the values around the mean. Okay, let's take an example on how can we calculate the absolute mean deviation. So let's say you have this table and you want to calculate the absolute mean deviation. So the formula is E equals summation. So this means summation, it's called sigma. Okay, it's nothing but you have to add all your answer. It's ni times the absolute value of xi minus x bar divided by the total frequency n. Okay, let's make it more simpler. So first of all, what you have to find is x bar. It means the average or the mean. Okay, x bar, you know that x bar is xi times ni divided by the total number. So it's 6 times 1 plus 8 times 1 plus 12 times 3 plus 15 times 4 plus 16 times 2 plus 18 times 2 divided by 13. Okay, you will get x bar equals 13.69. Then you do absolute value of xi minus x bar times each frequency. So I will make it here. Okay, so to save space I wrote x bar here, and this is the formula for the mean deviation. So E equals okay, you look at the frequency of the first one, it's 1. So 1 times the absolute value of xi, so it's xi 6 minus the mean x bar. X bar is 13.69. Okay, plus, because you have to add them up, summation. Same thing here, plus ni, so n here is 1 times the absolute value of xi, its xi is 8 minus the x bar, which is 13.69, plus ni of this is 3 times the absolute value of xi, so its corresponding xi is 12 minus x bar is 13.69 plus 4 times absolute value of 15 minus 13.69 plus 2 times the absolute value of 16 minus x bar, which is 13.69, plus ni here is 2 times xi is 18 minus 13.69. Okay, all of this you divided by, so you divide your answer by the total frequency, which is here 13. Okay, when you do this you will get as final answer the mean the absolute mean deviation is equal to, you will get as answer 2.84. So this is the absolute mean deviation. Sometimes the absolute mean deviation is denoted by NAD for absolute. Okay, if I didn't ask you about the absolute mean deviation, if I ask you about the mean deviation, you don't put absolute value of xi minus x bar, you just write it without the absolute value. So you write E equals summation of ni times xi minus x bar divided by n. Okay, for the absolute mean deviation you put here absolute value. So here you have to get always a positive number, no negative number, since you have absolute value. If you got a negative number, so your answer is wrong. So this is for the mean absolute deviation. Now we'll talk about the third characteristic, which is the variance and standard deviation. So we have two characteristics, not one. They are related. So okay, so variance and standard deviation. The variance is the mean of the squared deviation. So V is for variance is equal to the summation of ni times xi minus x bar squared. So it's the mean of the squared deviation, so divided by the total frequency. Okay, so here so let's go back to our example. Here we found x bar, the mean, it's 13.69. Okay, we have to find the variance. So V equals, we said it's Ni, summation of Ni times xi minus x bar squared divided by the total frequency. Okay, Ni here it's 1, so I already here wrote 1, so this is 1 times xi minus x bar squared, so remove the absolute value that we found in the mean deviation, so you put this squared plus same thing here, Ni is 1 times xi minus x bar squared, Ni is 3 for this one, xi is 12, so 12 minus x bar squared, and so on. Okay, so same steps, but you have xi minus x bar squared instead of absolute value of xi minus x bar divided by the total frequency, which is 13, and then you will get 11.9. So the variance here is 11.9. Now let's find the standard deviation. So the standard deviation is denoted by sigma. So this notation is read as sigma. Okay, and it denotes the standard deviation. How do we find the standard deviation? Actually, the standard deviation is the square root of the variance. So once you find the variance, okay, you just do radical of the variance to find the standard deviation. So let's go back to our example. So here we found the variance, it's equal to 11.9, so the standard deviation is equal to radical 11.9, we'll get 3.45. So this is about how to find the standard deviation. Actually, the standard deviation is helps us comparing the variability of values of two series. Let's say, for example, we have a series that has standard deviation sigma 1 equals to 1.7, and the second series you have the standard deviation equal to 9.2. Okay, here sigma 1 is less than sigma 2. This means that in this series where sigma 1 is smaller, the value or the data are not too much spread out around the value. It means that we don't have a much variability on the series, so it's more regular than the second one. Okay.